We left off in our last video with the tragedy that happened in the tunnel with the loss of 6 men from asphyxiation. The St. Clair Tunnel wasn't the only tunnel that was having this problem with the fumes inside the tunnel. This was happening in other tunnels as well, none under the water, but the ones through the mountains, such as the Cascades Mountain. The Great Northern's answer to the fumes being directed away from the engine with this right here. Quite unique engine, I would say. But that really didn't solve the problem either. The answer was electricity. As we continue in this video, as we did the last video, we're taking excerpts from an article or several articles that T.J. Gaffney wrote for the Lakeshore Guardian. He said this: "One must remember that the use of electricity was still very much in its infancy when Grand Trunk Railway began to look seriously at it as a replacement to steam in late 1904. Electric power could be found in several street trolley and interurban operations, to be sure, but the ability to haul heavy loads up significant grades via the electric propulsion was a concept that just didn't exist when the tunnel was built, and very few instances had been demonstrated around the country even 10 years later. As such, bids were obtained from several different companies for the possible operation. Very quickly, two chief competitors for the contract arose: General Electric, who proposed a DC current system of 600 volts, and Westinghouse Company, who proposed a 3300 volt AC system. One should make a quick note that throughout the country at the time there was a battle going on for who would win the electrical power war, AC or DC. Direct current was backed by Port Huron's own hometown hero, Thomas Edison, and AC by Westinghouse and one of Edison's former employees, Nikola Tesla. I'm sure that the fact that this installation was being made in Edison's hometown was not lost on either him or General Electric, and it must have been quite a blow when Grand Trunk Railway decided to let his contract for the project to Westinghouse Electric and Manufacturing. The reason was simple. Grand Trunk needed to not only power the tunnel motors in operation, but also required the system to operate the pumps needed at each portal for pumping out excess water, as well as electricity for lighting Port Huron and Sarnia tunnel stations, the Sarnia and Port Huron roundhouses, and lighting with both yards. AC could do this much more effectively and with fewer power generating units, and so they won the contract. If you're like me, you wonder what's the big deal now between AC and DC. I mean, there's a lot of scientific jargon, but it boils down to distance. Edison's system had the DC generator, as you can see in this diagram, and then it went out to, well, say, the first home or the first business. The problem is it couldn't go very far, and in order to go to the next one, they'd have to have a substation, because it could only go about a mile. And then they would need a substation again to boost the current up to where it should be. Grand Trunk needed the electrification of roughly 4 miles. If you include the yards in Sarnia, the yards in Port Huron, and the tunnel itself. And they were also taking care of the roundhouse, the turntable in the roundhouse, the electricity in the roundhouse, the tunnel stations. This is the Port Huron tunnel station, and this one here is the Sarnia tunnel station. And also the YMCA in Port Huron and the YMCA in Sarnia. Tesla and Westinghouse system, the alternating current system, was much more efficient. Instead of 600 volts, such as the DC system have, 3300 volts is going through the alternating current system. So that would leave the generator and go to the first transformer. And for example, on the roundhouses, they needed 3300 to turn the turntables, and that's what they got. But for the lighting system, they only needed 110, and so the transformer would reduce it to 110. Whatever it needed, the transformer could reduce it to that amount. A very efficient system for the Grand Trunk Railway. And that's what they purchased. Alright, that was my Mr. Science portion of the video. Let's go on to something else now. Grand Trunk specified the electric haulage system must be able to pull a 1,000-ton train between the two tunnel terminals in 15 minutes. and maintain a train speed of at least 10 miles per hour up to 2% grade leading out of the tunnel. The steam locomotives in use since 1891 could only pull trains of up to 760 tons. 6 new locomotives were ordered for the operation. The construction of these locomotives was a joint effort of the Baldwin Locomotive Works and the Westinghouse Corporation. Baldwin Locomotive Company was familiar to the Grand Trunk Railway. They had bought many engines from them prior to the tunnel, not the least of which was the 010 steam locomotives that were being used to pull the trains through the tunnel at that time. The new engines that were purchased were known as a box cab design. The locomotives each rode on a rigid frame with 6 driving wheels, and although each locomotive was numbered individually, they were in sense half locomotives, and were nearly always operated in tandem with another unit. As such, each pair of locomotives were bidirectional, and all were equipped in such a way that they could be operated in multiple pairs, a feature which allowed them to survive for many decades longer than their predecessors. The first trip made with electric power came on Thursday, February 20th, 1908, via engines 1308 and 1309. Which ran from Port Huron to Sarnia. Here they picked up a relatively light 700-ton freight train and returned back to Port Huron. All proved well, and over the next 3 months, the St. Clair Tunnel Company employees were instructed in their use. Here is the same photograph, colorized for a postcard, and if you notice the caption at the top, it says YMCA, Port Huron, Michigan. Well, as we've already seen, that's not the Port Huron YMCA, it's the Sarnia one, as you can see in this smaller photo here that we've already looked at. So you can't always trust the captions that are on old postcards. This lithograph gives a good idea of what the inside of these box cabs look like. Westinghouse Company personnel remained at the tunnel for 9 months, training the tunnel employees in the use of the new equipment. For 3 months, both steam locomotives and the electric models were used for haulage. The steam locomotives went out of service for good on the 17th of May, 1908. Westinghouse continued to supervise the operation of the system until they officially transferred control to the St. Clair Tunnel Company on the 12th of November, 1908. Over time, as trains became heavier, the tunnel company needed additional haulage capacity and bought 3 more electric locomotives in 1927. From that time on, they routinely ran 4 locomotives at a time and kept the 9th as a spare. So where did all this power come from that supplied the power to these electric trains and supplied the power to the electric pumps and the pump houses and all the lights that lit the yards and the roundhouses and the YMCA and over 400 lights in the tunnel? This is a good shot showing the inside of the tunnel lit, as well as both tunnel depots. And not only the depots, but also the airplanes that flew over it. Oh, wait a minute. That's not real. That was Mr. Pesha's sense of humor. He liked to insert this airplane in different locations around Port Huron as well as other cities. Well, to answer my own question about where all this power came from, it came from here, the powerhouse. This powerhouse was built between Military and the St. Clair River. I will show you exactly where later, but it was built almost exactly over the area where they started digging the tunnel in the first place. As a matter of fact, that vertical shaft that they had for the tunnel, they used that to supply the electrical conduits to go to the tunnel. It was an ideal location because it was close to the railroad. The track could run right along behind it. And it was also close to the river, so if ships want to come in and unload coal there, because that was the main thing they needed. The boilers are fueled by the coal, so they need coal both from the railroad and the ships. Here you can see the powerhouse under construction. Note that the powerhouse has a steel frame, which was unusual for the early 1900s. So with this steel frame and cement floors and brick walls, this building was virtually fireproof. Westinghouse needed steam generators to supply their current, and in order to have the generators, they needed boilers, and so they contacted Babcock and Wilcox to construct four 400 horsepower water tube boilers to do the job. These boilers had very large appetites, and they were fed by a relatively new innovation of the times known as a stoker. And this is a picture of a stoker here, and we'll look at it in a minute to see the stokers that were in the powerhouse. But these stokers, they allowed for a continuous semi-automatic feeding of coal to them via a screw or auger-like mechanism, greatly improving reliability and reducing manpower. This allowed for the capability to generate plenty of steam due to the surges directed by the electric motors as they pulled their trains up the hill into either Sarnia or Port Huron, without the fear of running out of steam and thereby shutting the entire system down. These are the stokers that were installed in the plant, 6 being used for each battery of 2 boilers, making a total equipment of 12 stokers. And you can see them on the right-hand side there. The generators themselves were 2 Westinghouse Parson model turbo generators designed to operate indefinitely at 3,300 volts. And everything was controlled from this switchboard. This switchboard allowed for the control and maintenance of proper voltages throughout the system. The powerhouse supplied the power to both the Port Huron rail yards, the tunnel, and the Sarnia rail yards. Well, let's see if I can tell you how this plant worked. You can see that the coal car came in on the tracks right behind the powerhouse, and then the coal was dumped out of the bottom of the coal car and went into the coal crusher. The coal crusher then dumped it into the elevator that went up to the top of the powerhouse into the chutes. Then it went down through the chutes and entered the stokers and the feed pump, and just was a continuous feed that went into the boilers. Once the coal had burned and turned to ash, the ashes were taken up in another elevator and down through a different chute and deposited in the coal car, and the ashes were taken away by rail. This is where it would be located today. And you can see the front part of the old powerhouse that is still there, still using that. But the part that was behind, as you can see in this opaque picture, that part's now gone. And as this clears up, you'll get a pretty good idea about where it was and what it looked like. So how was that power supplied from the powerhouse out to the yards and the tunnel? Well, that'll be in our next video. Also in our next video, we'll look at the diesels replacing the electric engines. And we'll also see they started using the fairy skin, because some of those cars now were just too large to go through the tunnel.